How's everybody doing today? Woo! My name is Joshua MacFie. I'm from McClendon Community College, and I was on the MDRS team or crew 139B. Awesome time with all these guys out here. To give you a little bit of a background of why I did the project that I did. I'm an electrical engineering major, and I was trying to think of what I could do for Mars. I was trying to think of a project, and I'm also a pilot. And as a pilot, I know all the systems in the airplane are really redundant. Everything, you have two of everything, stuff like that. And so I tried to start thinking, well, how can I make a flight to Mars, or living on Mars, more redundant, and give redundancy as much as I can, as every place possible. So I started to think, well, you could make everything modular, and have pieces that could be swapped out and stuff like that. How would you do that? So I thought FPGAs, microcontrollers, stuff like that. You can reprogram these chips to do different things for different purposes. So if you could take those and figure out how to do all your systems with those, your nav, your comm, your oxygen, your temperature, all the environmental controls and stuff like that, then if you had one thing that had more priority over another and it was going out, you could possibly pull this board out or this switch out and replace it with this one while you're working on it, and then once you get it fixed, you can swap them in and out and stuff like that. So I had to decide what I was going to start with, because I can't just go out and build a ship and start doing all the controls for it. So that is what led to my project, was automated environmental regulation, and more specifically for my project was to do temperature control using an FPGA and a microcontroller. So why? When we get to Mars, and on the way to Mars, we're going to need plants for oxygen and food, animals for observation, and we're going to need to keep the temperatures and oxygen and stuff controlled for human homeostasis. I mean, unfortunately, we have a very small window as humans, animals, plants that we can live in, and that's what we need to be able to control. So that's why we're going to need to control the temperature. Why MDRS? MDRS is a very extreme environment. I wanted to be able to take my project out somewhere that has, the desert, and it's hot, and it's really cold, and it's not doing it inside. In fact, I actually tried this inside and it worked great, but we'll get to that later. So also, because it's a solitary environment, there's a very small window of data that you can use while you're at MDRS. So if something goes wrong and you need to research it, you either have to petition your team and everybody else for time or data usage, or figure it out on your own. And so I wanted to see kind of how that went at MDRS. And also lack of tools and equipment. Whatever you don't bring with you, you don't have. And of course, going there, you have to fly on a plane, so you're limited to a certain amount of luggage and stuff like that. So the objective when it came down to it was to create a portable, automated environment that I could bring with me that regulated its own temperature and logged that data over the time that I was at Mars, or MDRS. And then I could take that data and look at it later on to compare it, see how everything worked out. The plan was to build a thermostat using an FPGA and a thermal sensor. The thermal sensor had to be a data thermal sensor because of the FPGA. Anyways, I'll give you that again. And to build a habitat using clear acrylic panels and using Peltier heat pumps. I wanted to use Peltier heat pumps. It's kind of a newer technology, but it's a very light way to heat and cool environments. And I thought, well, I'll give it a try, because anything that's going to have to go needs to be lightweight, and we'll see how it works. So my materials list, I used a Mojo FPGA control board as part of my development, and also an Arduino microprocessor. Those are the two main boards, and those would be what you would use in the modular design of everything. Of course, these are pretty big. When you actually design for something like this, everything's going to be printed on a circuit board, everything's going to be small. This is kind of just a prototyping kit and stuff like that. I also used an SD card shield for the Arduino, 16:2 LCD screen to be able to read temperatures and stuff like that. Temperature probe, which was the digital temperature probe. Peltier heating devices, which are the hot and cold on one side or the other. A small habitat, and various electronic components just for hooking it all together and making it all work right. As far as the execution, this is kind of an overview of the entire project. I'd like to go through it all just so y'all kind of have an idea of how this stuff works together and how you might be able to take these things and make them modular. So the FPGA controls the LCD, and it also controls the transistor circuit which runs the relays. And you've got a temp switch that's set to the FPGA. And then there was also, I had to create a communication protocol between the Arduino and the FPGA. The Arduino microcontroller runs the read-write card, the SD card, which takes all the data, and it also reads the temperature probe. To go a little bit more into detail on that, the liquid crystal display that I decided to use was something off the shelf, LCD 09053. To kind of give you an idea, with the FPGA and the Arduino are two separate environments to program for. The Arduino is a very software-based programming environment, and the FPGA was a very hardware-based programming environment. So with the hardware-based programming environment, you have to consider clock times and stuff like that, and use more combinatorial logic and stuff like that. So this is kind of a very long hardware descriptive language snippet of code that I used to turn on the enable pin and turn off the enable pin as data was being sent. So you send data to this thing. When you send the data, if you don't have that enable pin on, it doesn't receive any data. So you have to turn that enable pin on, then send the data, and turn the pin off. And that also keeps it from, if there's fluctuations in the circuit and the enable pin is on, it'll catch a bunch of stuff. It's kind of a keep all the noise out type of thing. So the description language down there, I use just combinatorial logic to combine counts of the clock in the FPGA, which you would have to do with actual hardware, and you wouldn't have to do that with the Arduino. Next is the temperature sensor. Like I said, I had to use a digital temperature sensor, and this temperature sensor turned out to be a really, really great addition to my project. One of the cool things about it is it's a one-wire device. You can power it, you can take the temperature from it, you can talk to it all with one wire. And even with that, you can connect multiple units onto one single wire. They go all the way out up to like 50 some odd, depending on how long your wire is. So one single pin on one of those FPGAs or Arduinos can be used to read and to control several different temperature devices, and that leaves a whole nother board worth of pins for doing other things like oxygen, humidity, Navcom, stuff like that. And it also takes the power out there. This is kind of just the way that the temperature sensor works. It sends data with the enable pin, like I was saying earlier, and it has a clock. So one of the problems that I ran into, I got the FPGA hooked up to the relay board to turn on and off the heating devices and the fans and stuff like that. And I was trying to get it to run, and everything looked like it was working great, but the relay wasn't kicking on. And I wound up figuring out that I wasn't pulling enough amperage with the FPGA. So I built this little transistor circuit to basically create an amp draw every time the FPGA told it to kick on. And so we used this transistor circuit to kick on the relays, and it worked out great. But it did cause a problem later, which we will talk about. The last thing is the read-write card. One of the cool things about the Arduino is that they're built very configurable, and they have these little cards that you can pull for just about anything you want to do digitally. And you swap these cards on top of the Arduino, and they have multiple libraries for all these cards where you can pick up the library, and all you have to know is how to program a regular language, a pretty normal software language, and you can program for these cards. So it turned out to be pretty good. I could just pick up that SD card and throw a program down. In fact, that was something, this whole project ran so long because I did more than I had expected, that this wound up running into the last week before we left, and I was able to write a program without actually hooking it up, and most of it worked just fine. And in the middle of the trip, just as you guys are kind of surprised, we felt really surprised. Fox News showed up, and they brought out cameras to take footage of us and ask us questions and stuff like that for the Exploration Outer Space television show, I guess, which is coming up this fall. It was really interesting to me to have this extra new added thing coming in on us while we're all like, we've been in there a few days and we just got ready, got set, kind of getting to know each other. We could have scheduled down, and then we knew they were coming, but it was still a shock to the system, And so they come in and they start asking questions, and I think we overall did really well as far as our whole team. We pulled together and got it done, but you could tell there was a ton of extra added stress there, And when we go to Mars, there's going to be lots of unexpected stressors and stuff like that. So it was really interesting to see how we handled it, and it turned out pretty cool. And I'm kind of excited to see me and my teammates in the show. It'll be cool. So I don't know much about it, but if you want to know, probably Google exploration outer space, and there's probably a lot of info online about it. At MDRS, when we finally got there, had to deal with a few things, shipping and handling damage. This is the same kind of thing that you can have, when you fly or when you take a ship up, all the G's and stuff and mess with stuff. As I was showing y'all earlier, the transistor circuit, these are just transistors put into a little breadboard, and they're kind of loose. And all my wires this is all a development environment. It's not all soldered down. So, when the bags are being moved and things are being shuffled around, some of my transistors in that transistor network popped loose, and some of the wires popped loose. So the first day and about midway through the second day was just kind of piecing back together all the little things that had come loose and figure out what goes where. And then I got it up and running, and everything worked great except for the LCD, not the LCD, sorry, the read-write card, the SD card. It would take, probably 20 data points and then shut down. And it was a bug in my program, and I couldn't look up this information. I couldn't research it online. So I spent another, half a day to a day just trying to dig through my code and figure out what had gone wrong, and figured it out, got it up and running. And so I didn't really get the data to start logging on the digital card for large amounts of time until toward the end of our rotation. But before that, I had kept the whole unit running because it was running fine. It just wasn't logging the data, and I took physical temperature readings of myself and wrote them down. And then once I got it up and going, I logged data for analysis. The actual data. This is where we see the problem that comes up. Those little Peltier heat pumps. I'm an electrical engineer. Unfortunately, I'm not a mechanical engineer, and I haven't taken thermal. I did not hook these things up well enough. I mean, they're really tight tolerances to get these things to work right. And once you get them to work right, they work great. So you can see the blue line on the bottom is the actual temperature inside, and the red line on top is the actual temperature outside for the graph on the right. And it's blue and red on the graph on the left, but this is kind of during the day, and this is in the morning. So the temperature inside the microhabitat held within tolerable levels, but you can tell that it's just kind of climbing with it because those heat pumps just weren't doing it enough. And so as it climbed, it still climbed. As the morning came around, it seemed to heat better and keep it a little hotter, but once it started to climb, it took a while to catch back up to it. So it worked out well, and if I had different heating and cooling devices or learned how to better hook the Peltier devices up, I think it would have worked out just great or phenomenal. So in the future, obviously I was talking about earlier, I want to be able to control multiple systems. I want to see how many systems I can put onto an FPGA, or how many different types of systems I can put on an FPGA, and reuse different small components, transistors, resistors, and stuff like that, where you could do modular type units and swap stuff in and out. I'd also like to create an artificial intelligence just for this actual project for the temperature regulation. Once I get the heating and cooling working right, something that could record day after day and kind of set up per day. If it's climbing, it usually climbs around 2, so we'll start at about 1:30, cooling it off, and then maybe even move into months, months of data. And this month gets a little bit hotter than this month, so we'll get it ready to cool like that. Also, like I was saying, I'd like to control other environmental factors, humidity, oxygen, stuff like that.
Like the Nest thermostat, I guess.
Yeah. Any questions?
We walked in just a tad late, so I kind of missed the premise of what you're trying to do.
Well, the way I came up with this project is I would like to build modular units. Like when you fly an airplane, you have you have redundancy for everything, right? So you have 2 vacuums for your vacuum machines. You have 2 alternators for the airplane, stuff like that. So when we go to Mars, we're going to need a lot of redundancy. And the idea kind of that I have would be to make everything modular and try and make everything where it could be redundant. So say you've got a nav system, if you can make that nav system out of, say, FPGAs or microcontrollers, where you could, if you had 3 nav systems, 2 environmental systems, one of your environmental systems is getting jicky, swap those out because your environmental is more important, right? And then fix the chip that's on there, and then swap them back in, stuff like that. Or, you know, I mean, if you're flying back and you really need oxygen more than you need navigation, so, you know, or something like that. That was kind of the premise behind this. And then I had to pick a project that was like, you know, where do I start? So I decided to start with temperature regulation. Did that answer your question?
Yeah.
Did you actually, did I miss, was there a picture of what it looked like?
At the very first, I think.
Okay, was that what that was at the beginning?
F5.
Okay, so you were actually growing like was it just by itself or did you have a
Well, I
plant?
had, there's an orchid and a pothos ivy inside the environment. This is the actual project. You've got the relay board at the bottom there. The breadboard's kind of got everything on top of it. Arduino with the SD card is on the right center. Up top in the middle, the black board with the green letters is the FPGA development board. And then on the right is the LCD that read off my temperatures and stuff. And then the probes come out through here, and all the power was coming to the bottom.
So did the plants live?
Yes, although the news crew came in, the orchids don't like a lot of light, not desert light, so I had a shade on them. It wouldn't really change the temperature, but they moved that shade because you know they were trying to get around the greenhouse and stuff like that, and I didn't catch it in time. So the orchid lived, but he wasn't doing good. The pothos ivy trooper around.
My question was, the purpose of this was to have it be redundant, so you could switch it out with another system, right? So is your next plan to do another system, have them there so you could switch out the parts?
Sure.
At some point, actually,
Well,
test it.
Immediate future would be good to try to put all the environmental controls, you know, I could do oxygen stuff on one of the boards, and then maybe move on to doing NavCom. And I am a student, so learning along the process is the best part. But, you know, maybe do a NavCom alongside, and then just see how hard it would be to swap back.
So it wouldn't switch between environmental controls, it would switch between the navigation and communication system, and that's the real purpose.
Something like that, yeah.
Switch.
Anybody else?
Arduinos are awesome.
They are awesome. And then Arduino is really a lifesaver. I love programming in the FPGA, but
Have you thought about using, some of the thermal controls and some of the sewable Arduinos, the ones that are built right into fabric and stuff like that, and doing some thermal regulation inside a suit?
that would be fantastic. I hadn't thought.
Yeah, there's sparkfun.com.
Okay, yeah.
Yeah,
That's right.
so it's all the stuff you need there.
Very nice. I'll have to check that out.
How hard is it to program an Arduino?
Arduino is actually fairly simple. If you know any Java, C, anything like that, move right on over to.
Yeah, it's real straightforward.
Yeah.
They're in 6th graders to learn how to do it too.
Oh, shoot, I can do that then.
The FPGA is a lot more difficult, but it's like a totally different world between the two.
You have 11 minutes if you want to continue.
Continue.
Dance.
What do you want to do next time? What do you want to build? Do you want to continue with thermal for a while, or?
Yeah. Well, I've been thinking a lot about flight systems and stuff like that. I'd like to do
Like a
once I get this fully set out, I'd like to do like a copter or something like that to start learning gyroscopes and all the nav systems and flight attitude systems, stuff like that. Would be awesome.
You ever thought about taking one of your designs and like getting it, like you can send schematics off the shine and then they send you a board like a
Yeah.
month or two later or something like that.
I have, but I need to come down and come up with something solid that's not, I mean, this is kind of, you can do this with temperature gauge. Granted, this thing you can run, 200 temperature gauges off of, 3 different cores. But I mean, I want something solid that was original. that I
You're,
knew something.
you're aware on SparkFun that they have the weather shield that has all sorts of temperature, humidity, blah, 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 already built together.
Yeah, I was just, especially, the main thing here was the FPGA. I was learning combinatorial logic and stuff like that. And I like the idea of reprogramming a chip because the FPGA does it all hardware style. So you're actually building the chip inside of it. I think it's fantastic. So I was kind of getting into that. Yes, ma'am.
So you did the heating and cooling of that little environment. So say you're gonna do a room, how much bigger would that have to be?
This actually unit would stay the same size. The only thing that would change would be the relays and the power coming, which actually those relays, and they wouldn't be able to handle a room cooling and heating. But
Yeah, the size of the heating elements and stuff.
right.
I realize you brought up the point about there already being things for monitoring, but wasn't the objective of this to sort of create a redundant system where you could use more or less 21st century interchangeable parts, and that was just the guinea pig on which you chose?
Yeah. Just
Cool.
kind of a thing to,
Yeah, so I mean, you could have chosen lots of different things, but that was just the place to start.
Sure.
I think the object was more of the process of programming and repurposing as opposed to one specific element that was already done through the shield, for example. At least if I understood you correctly.
Yeah.
Cool.
Anybody else? Apparently I still got time.
So you were actually regulating the temperature inside the little habitat, right?
I was, it just wasn't regulating it well enough. I needed more power, more heating.
Need more neutrons.
Yes, there you go.